Dear viewers,
welcome to the Engineer channel for learning and benefiting. In a new video today we are talking about heat treatment furnaces. Listen to the latest videos so that you can benefit from something important in the furnaces from this book. Heat Treatment Equipment, 2nd edition, George E. Totten, N. Gopinath, and David Pye. Introduction. Some of the most important decisions that the heat treater will make are related to the selection of furnaces and ancillary equipment. These decisions involve selection of the energy source, gas or electricity, which is vital to the overall profitability of the heat treatment process. Another is the selection of the furnace transfer mode, batch or continuous, and the particular furnace type. If a furnace is rebuilt, the proper choice and installation of the refractory material are vital. In this video, the selection and operation of heat treatment equipment are addressed. The focus of the discussion is on the furnace atmosphere generation, and ancillary equipment. Discussion subjects include furnace part transfer mechanisms, furnace heating, heat transfer principles and application to furnace calculations, atmosphere generation, atmosphere sensors, thermocouples, refractory materials, fans, fixtures, parts, washing, quenching systems, furnace safety, salt bath furnaces, fly-diced bed furnaces, furnace transfer mechanisms. Heat treatment furnaces are classified as batch, semi-continuous, or continuous. In batch furnaces, which are the most common and most versatile in the heat treatment industry, the work is typically held stationary in the furnace vestibule. The furnace is loaded or unloaded in a single batch mode operation. In continuous furnaces, the load moves through different zones, usually with varying temperatures as shown in Figure 1.1. Parts that are heat treated are moved through the furnace in a continuous process. In semi-continuous furnaces, parts move through in a continuous but stepwise manner. For example, they may move through the furnace in a tray or a basket. As the tray or basket is charged from the furnace, it is quenched. After the quench cycle is completed, the tray or basket moves on. The next one is discharged from the furnace and quenched, and the process continues in a stepwise manner. A comparison of the features of a few select examples of each furnace is provided in Table 1.1. For the purposes of this discussion, semi-continuous furnaces are considered to be continuous. Batch-type furnaces discussed include box, pit, integral quench, IQ, and tip-up, both circular and car-bottom. Continuous type furnaces discussed here include walking, beam, rotary hearth, pusher, roller hearth, conveyor, shaker hearth, screw conveyor, and rotary retort. Table 1.2 provides a selection guide for these types of furnaces as a function of the heat treatment process. Batch furnaces. Box furnace. The box furnace, such as the one shown in Figure 1.2, is the simplest heat treating furnace. It is used for tempering, annealing, normalizing, stress relieving, and pack carburizing. It is capable of operating over a wide range of temperatures, 95-10958 C, 200, 20008 F. Table 1.2 Furnace Selection Guide. integral quick sealed quick furnace. IQ furnaces are among the most commonly used and most flexible furnaces for processing small parts. They can be used for either neutral or atmosphere hardening processes in addition to normalizing and stress relief. IQ furnaces are similar to box furnaces except that the quench tank is located at the discharge end of the furnace as shown in figure 1.3. As the parts are removed from the furnace, the baskets used to hold the parts that are heat-treated are lowered into the quenchant with an elevator. The attached quench tank can be a disadvantage because the bath loading and height of the baskets restrict the size of the parts that can be quenched, too. Another limiting factor is the size of the heating chamber. Economics typically dictate that the largest furnace available with respect to the amount of work to be treated be used. Furnace design developments have led to ever greater automation, reduced cycle times, and greater fuel efficiency of these furnaces. 5. Cycle times at temperature are reduced even with newer furnace designs. High-temperature carburizing is not practiced because of the limitations of materials engineering. Pit furnaces. Pit furnaces are circular furnaces that can be either floor or pit-mounted. They are used for such processes as annealing, carburizing, tempering, normalizing, and stress relieving. Some of the advantages of the circular furnace are the smaller heat release areas in comparison to box or rectangular furnaces, more uniform atmosphere, improved temperature distribution, and smaller furnace body weight. 6. A pit furnace is shown in figure 1.4. Such furnaces may also be used as pit carburizers or nitriters. So here we are satisfied with this video, so that I will not be longer in time. And you can continue in a video coming, God willing. If you like the video, press like and subscribe to the channel. Thank you.